So I've got a slightly annoying problem with one of my dev boards. So these are the dev boards that I got made by PCB. So they did the PCBs and they came out really nice. And I did the assembly. Now obviously something's gone wrong somewhere. I got these boards running a very fast blink sketch. So hopefully you can see there's a flashing LED here and a flashing LED here. It's more visible here because it's a green LED. Should use green LEDs on both the boards. But let's see, if I hit the reset button, then the flashing stops on this board. So this reset button is working nicely. If I do the same on this board, absolutely nothing happens. The flashing light continues, so I can't actually reset this board. It's a bit annoying because sometimes you do have to go into programming mode by holding down the boot button and then pushing reset. Obviously, I can't do this, so I'm constantly having to unplug and replug in this board. This one works fine, so we can hold down boot, hit reset. Now we're in programming mode, and until we hit reset it will stay like that. This board is great, this one not so good. So I do want to check the schematics and the PCB layout, make sure it's not some fluke that this is working. So let's jump over to the laptop and have a look at the schematics. So here's the schematic, and here's the bit of interesting stuff. Absolutely nothing wrong with this. We have the switch, we have the RC circuit, so a resistor and a capacitor connected to the EN pin, which is over here. So that looks fine. Let's jump into the PCB, make sure that's correct. So here's our PCB. So here's our reset switch down here. So it pulls down to ground. There's the EN pin there. And if we trace this up, go under a via, come across to here, and we come to here, and then here. So that looks fine as well. So this is the capacitor, that's the resistor, and then this trace carries on all the way up to the EN pin. So absolutely nothing wrong there with either the schematic or the PCB layout. So let's try buzzing out this path. It should be fairly simple to buzz out. Okay, so EN pin, so that's ground, 3.3, and this should be the EN pin, and then that should go to this end of the resistor. So that's working fine, and then it should also go to the end of the capacitor. That works fine. Should go to the switch. Well, that seems to work fine as well. And I'm going to do this. If we go to the other end of the switch and then push the button, this is where you need multiple hands. Well, that's interesting. This button doesn't seem to be doing anything. We should be hearing beeps. Let's just double check that's either side of the button. Push it. Yeah, we're not getting any continuity across the button. Well, that's a bit annoying. Let's check our boot button. Definitely works. Let's check that does actually. Yeah. So if we can get the probes on there and then push, that works. On this one, absolutely nothing. Okay. Well, I hope you could see that. It's quite fiddly work, but let's have a look under the microscope, see if we can work out what on earth's going on. So we're under the microscope, so let's just check the soldering of everything. So this is the ESP32 pins. It's got ground, 3v3, and this is the enable pin. And to my eye, if we focus this, that looks pretty well soldered, so not a problem there, which the buzzing did confirm. If we go to here, then we can see the RC divider. So we've got our capacitor and our resistor. They both seem completely fine. And then down here we have the button. Now it's hard to see, but looking at this, I cannot really see any problems. It does look to be pretty solidly soldered. So quite intriguing. Let's check the other button, see how it compares. I mean, it's a bit more shiny, but there's nothing obvious that would make this button not work. So the only thing I can really think is to reflow the joints and then see if we have any joy. So let's give that a go. So we'll just squirt a bit of flux down here. I mean, that looks disgusting. Everything seems to look quite horrible when you're really zoomed in. To me, looking from a distance, this board looks completely clean, but then you stick it under the microscope and there's all sorts of nasty, hairy things on your PCB. So let's see if I can get in here and just reflow these joints. Now I can actually feel on the solder joint, I can feel the switch connector, so it's definitely should be soldered on. Let's just do the other side just for completeness as well. Okay, a little bit of flux. And that's pretty solid as well. I can feel the connector, no problem. So, well, let's give this a go. Let's buzz it out. It's definitely clicking. So let's get the multimeter. No, well that's interesting. It is the actual button that's dead. This button. Oh no, there we go. We had it, and then we don't have it. And the button does seem to be quite full of flux. I wonder if that's causing a problem. What I might do is I might soak this in IPA and see if we can resurrect it. Otherwise, we'll just remove the button and replace it with a new one. But I'm going to try a bit of IPA soaking. Well, I think we may have fixed it. It's still covered in IPA, but if we come in and probe it, and we push the button, absolutely no problem at all. So I think it was just that our button got filled up with flux and then it wasn't making a good contact. So well, let's plug this board in and see if it really does work. So here we are. We have our flashing LED, reset button. Let's see if we push the reset button, does the flashing stop? It does. Well, that was a remarkably simple fix. A bit of cleaning, that's all it needed, and it's right as rain. So, valuable lesson for me. Use more alcohol. That's the conclusion I'm taking from this.